Hello, and welcome to this presentation, Understanding Power Supply's Derating Curves. In this short presentation, we'll explain what power supply derating curves are and how to interpret them. Benchtop or bench power supplies have three primary specifications. These are maximum output voltage in volts, maximum output current in amperes, and maximum output power in watts. These are usually specified per channel for both single and multi-channel power supplies. When operating a benchtop power supply, the user normally configures both the desired output voltage and the output current limit, or the maximum amount of current that can be drawn from the power supply. The latter is usually for safety reasons and or to protect the load. The output power is simply the product of the configured output voltage and the amount of current being drawn by the load. Here, the configured voltage is 8 volts, the load is drawing 3 amps, so the total power output is 8 times 3, or 24 watts. Mathematically, if both voltage and current can be varied, then there are many ways to produce the same output power. For example, we could produce 40 watts using 40 volts and 1 amp, 20 volts and 2 amps, or even 100 volts and 0.4 amps. Practically speaking, however, all power supplies have limits on the output voltage and current that they can produce, and this is a function of the power supply design. In many cases, maximum current is the limiting factor. For example, it's relatively easy to design a 40-watt power supply that delivers 1 amp at 40 volts, but it's not quite as easy to build a supply that would provide 40 amps at 1 volt. Even in the case of normal voltages and currents, a given power supply design might not allow all combinations up to maximum voltages and maximum currents. For example, a power supply that is specified with a maximum current of 2 amps and a maximum voltage of 100 volts might only be able to supply 40 watts instead of 200 watts. This is actually not uncommon. In addition, we might only be able to use certain combinations of voltages and currents to achieve the maximum output power of 40 watts. For example, 80 watts and 1/2 amp might be supported, but at 40 volts, only 0.75 amps is supported, and this leads to a less than maximum output power. Since voltage and current can take on a wide range of user-configured values, it would be difficult to express all of the allowable combinations of voltage and current in tabular form, and therefore this data is usually represented graphically. Derating curves are used to graphically represent the combinations of voltage and current supported by a power supply. On the right is an example of a typical derating curve, this one for a 160-watt power supply. Any combination of voltage or current that falls on or below this curve, that is, in the colored area, is supported by the supply. Derating curves are normally included in the power supply specifications or manual, or they can be found on the manufacturer's website. In some cases, you may even find the derating curve physically printed or stenciled on the supply itself. Whenever using a power supply, it's always a good idea to check the derating curve to ensure that the desired combinations of voltage, current, and power are supported. Let's take a closer look at a classical derating curve. This supply has a maximum power of 160 watts, a maximum current of 10 amps, and a maximum voltage of 30 volts. Again, it's important to remember that for most power supplies, the maximum output power is not maximum voltage times maximum current. On classical derating curves, there's usually a curved region bounded by something called the maximum power output curve. As the name implies, all points, that is, voltage and current combinations, that lie along this curve will yield the maximum output power, here 160 watts. For example, at this point, we have 16 volts times 10 amps, and at this point, we have 30 volts times 5.3 amps. Although many power supplies have classic derating curves similar to the one we just looked at, other derating curve shapes are also possible. Here, the power supply has a maximum output power of 40 watts, and instead of a curve, we have a maximum power output line. As before, maximum power output is achieved when the combination of output voltage and output current lies along this line, as shown by the examples here. Let's end with a brief summary. The primary specifications for DC benchtop power supplies are maximum voltage, maximum current, and maximum power. It's important to remember that maximum output power is usually less than the product of maximum voltage and maximum current, and that even below maximum output power, there may be combinations of voltage and current that are not supported. Derating curves are a graphical way of showing which voltage and current combinations are supported, with allowable combinations lying on or below this line. Many derating curves also contain a maximum power output curve, or line, for determining which voltage and current combinations can be used to produce maximum output power. Derating curves are therefore very useful when determining if a power supply can meet requirements for voltage, current, and power. This concludes our presentation, Understanding Power Supplies, Derating Curves. Thanks for watching.